All right, let's go ahead and get started with a lecture on odds. So odds are mostly used in betting, a lot of times in sports, but really any type of betting contains odds a lot. And there's something that actually you see quite often, and at least for me, every time I saw them before I kind of learned about what they were, I was always confused by exactly what they meant. So let's go ahead and get into this. So what odds do is they give a comparison between the number of favorable outcomes and the number of unfavorable outcomes for a specific event. So let's say that I have an event, and we're going to go ahead and just say event is me winning a game, whatever it is, maybe some sport that I'm playing. But the event is me winning that game. So when we say favorable outcomes and unfavorable outcomes, we're referring to whether the event has happened or not happened. Something we want to be careful about here is we don't want to say, oh, favorable means winning and unfavorable means losing. Obviously, those words have that connotation, but when we say favorable and unfavorable, we're talking about whether that event happens. So in this case, if the event is me winning the game, a favorable outcome would be that this event happens, which means that I win. An unfavorable outcome would mean that the event didn't happen, which would mean that I lost or maybe even tied, just that I didn't win. Here's something you could do that to kind of get this point across. You could change this to saying, what if the event is me losing a game? Well, in that scenario, the favorable outcome would be that I lost. And that sounds weird, of course. We don't tend to think of losing as favorable. But if this is the event that I'm talking about, then a favorable outcome is when that event actually happens. And so the favorable outcome in this scenario would be me losing the game. The unfavorable outcome would be me not losing the game. So either winning or maybe tying, depending on what the game is. What we say with odds, we use two different descriptors to talk about odds. We can say odds are in favor or odds against, and they're basically just opposites of each other. Let's go ahead and get into those. So let's say that we have an event E, that's what we've been talking about, maybe me winning or losing a game, or just some sort of event. Maybe I'm flipping a coin, maybe I'm drawing from a deck of cards, any event that we're dealing with. That event can have favorable outcomes and it can have unfavorable outcomes. Either it happens or it doesn't. And what we're gonna say, notice this A is italicized here and this B is italicized. This A and B here, these are variables. They stand for numbers, and it's saying that we have A, favorable outcomes, and B, unfavorable outcomes. Maybe if it's easier for you, you could think of this as like X and Y, but we'll tend to use the letters A and B. So what we write is, if we're talking about the odds in favor of an event happening, then we're going to write this notation here. We're going to say A with a colon and B. So what I might say is odds in favor of me winning this game or whatever we're playing are 2 to 3. And if I write that, what I'm saying here is that the odds in favor of me winning are 2 to 3. And so 2, you'll notice, corresponds to A. And 3 corresponds to B. So we have this sort of matchup here, 2 to 3 and A to B. So we know that A is 2 and B is 3. And well, we've said that there are A favorable outcomes, meaning there are 2 favorable outcomes, and there are B, meaning 3 unfavorable outcomes. So when I make a statement like this, what I'm saying is I'm just telling you how many favorable outcomes and how many unfavorable outcomes there are. I'm telling you that, hey, 2 times I won and 3 times I didn't win. And so that's all we're saying with this statement here. Basically, when we write out this 2:3, it's just a way of notationally writing how many favorable outcomes and how many unfavorable outcomes there are. It's just a little bit faster than saying, oh, I'm going to win 2 times and I'm going to not win 3 times. Writing that out in a sentence is just bulky. So this is just a little bit quicker. Now, What we could do is we could say almost this same exact thing here. And I'm even just going to copy this down, but I'm going to change one little thing here, and I'm going to write odds against me winning. Oh, little typo there. Odds against me winning. There we go. So if I say instead that the odds against me winning are 2 to 3, while this looks very similar, changing this word, this phrase in favor to against, changes things a lot. Now, when we talk about the odds against this event happening, we're basically saying that because we're talking about odds against, the first number written here is now B instead of A from before. So since that first number is B, that's telling me the number of unfavorable outcomes. And then the second number is A, a placeholder for A, that tells me about the number of favorable outcomes. So in this sentence here, I'm telling you that I was unfavorable to me winning, meaning I didn't win 2 times. Up here, I told you that I actually didn't win. I was unfavorable to winning 3 times. And then vice versa here, 3 and 2 for not winning. Or excuse me, for winning. Yeah. So we've got just the flip there, and you notice changing that word changes things right there. You'll notice that these are just reciprocals of each other. They're just opposites. And so really, if you find the odds in favor of an event or the odds against an event, you can just flip it, and that'll give you the other odds, either against or in favor, just the opposite there. Sometimes what we'll do, and we'll see examples of this, sometimes we'll write this as a fraction instead of as a colon. It's just notationally a little bit different, but there is reasons for it. We'll see that in a second. So if we talk about an event happening, we have that event either occurring or not occurring, and that is, that gives us outcomes and certain numbers of them. And so we can talk about odds either in favor or against with that. So let's look at an example here. So back in 2017, the odds against the Cleveland Cavaliers winning the NBA Finals were 5 to 2. Now we got to be careful here. Notice we're saying odds against. So we have that word against right in there. And so the odds against them winning were 5 to 2. So what this means is that this is going to look like B to A. Remember, odds against follows that B to A. And if we hopefully remember, A stands for the number of favorable outcomes. And so that's going to be 2 favorable outcomes. And then we have unfavorable outcomes, which is going to be B, and that's going to be 5. So when I write this odds against were 5 to 2, that tells me how many unfavorable outcomes there are. And now the question is, what is our event? Well, our event is that they won the NBA Finals. You can see that right here. The Cleveland Cavaliers winning the NBA Finals. So that's our event. So that means that favorable to that event means that they won. So if they win twice and they lose 5 times, then what we could say is, hey, if they played 7 times, they would win twice and they would lose 5 times. Basically, out of all of these sort of iterations of running this, playing this game, right? Playing the NBA Finals, doing this event, if there are 2 times that they won and 5 times that they didn't win, clearly there's 7 total times that we're sort of simulating this NBA Finals, and they won twice and they lost 5. So what that actually tells us is it actually tells us the probability that they've won or not. And actually, I'm noticing a little typo here. This should say the probability, not odds. So we have the probability that they win is 2 over 7, because what we've said is that there's 2 favorable outcomes out of the 7 total outcomes that there could be, and two of those are them winning. And the probability that they lose, yet again, this should say probability right here. So the probability that they lose is going to be, okay, well, there were 5 outcomes of them losing out of 7 total outcomes. So the probability that they lose is 5/7 right there. So we've got that right there. And really what we've done here is we've taken this odds against, we've taken this 5-2, and we've turned it into a probability. We've turned it into saying, all right, if there are 5 unfavorable outcomes and 2 favorable outcomes, that means that the probability of a favorable outcome is 2/7, and the probability of an unfavorable outcome is 5/7. So we've got that there. What we've just done there is really a formula that we're going to deal with. We've said, all right, if I have an event and if I give you the odds, either in favor or against, it doesn't matter what I give you, but if I give you the odds, then I'm giving you A and B, and you know what those both are. So if you know the number of favorable and the number of unfavorable outcomes, we can say that the probability of that event happening is right here. And now let's take a look at this carefully. When we talk about the probability of the event happening, what we want to say is how many times does it happen, and divide that by how many times do we do this event. Well, the number of times that an event happens is given by the number of favorable outcomes, which is A. So that's the number of times that this event E occurs. And the number of total times that we run this sort of experiment, or maybe we play this game, the number of times we play this game, that's given by the number of favorable outcomes and the number of unfavorable outcomes. That's the sum of A and B. Going back here, we said, hey, they won it twice, they lost it 5 times. That means they must have played it 7 different times. And so A plus B gives me the number of times that this game or this experiment is played out. And so out of those 7 times in this past example, they won twice. And that's exactly how we got 2/7 before. We just added the number of favorable and unfavorable outcomes, and then we just did favorable divided by that. So that gives us the probability that the event occurs. Now, what you could see here is that the probability of the event not occurring, we have 2 different ways we could think about this. We could go back to what we've seen before, and we could say, all right, well, the probability of something not occurring is just 1 minus the probability that it does occur. So even forget all of this over here. This right here is the probability of the event not occurring. So if you knew P of E, you could just take the complement and you could just do 1 minus it. There you go. Now, what this actually turns out algebraically, it turns out to look like this. And if you wanted to, you could write this very equivalently like that. B plus A and A plus B are the same thing. I maybe like this a little bit more. So let's go ahead and look at that. Well, what we're saying is the probability of it not occurring is the number of times that it does not happen, which is given by the number of unfavorable outcomes, B, and divide that by the number of total times we run this experiment, which again is just A plus B. And so this right here gives us a nice formula for the probability of an event not occurring. And again, all we need to know is just A and B, which will be given in like a problem statement where you'll be given that in the odds, whether they're in favor or against. You'll know A and B. So there's probability given odds. So we find probability and we're given, if we know what the odds are. Let's flip that around and let's try and find the odds given the probability. And this is where things might get a little bit trickier. So let's say I tell you, let's actually, before we look at this slide, let's go ahead and just work out an example here. So I'm going to say the probability of an event occurring is 42%. And now remember, we could write this instead as 0.42. We could write this as 42/100. We could simplify that 42/100 down, if we wanted to. There's a whole lot of ways we could write this. I'm just going to go ahead and write 42%. So that's the probability of an event occurring. And what we want to do is find the odds in favor of the event. And we also want to find the odds against the event. So we got those two things that we want to find. Well, let's go ahead and look at this. So if we take the odds in favor, for example, let's go ahead and look back here at odds in favor. So we said that we could write the odds in favor as A divided by B. We mentioned briefly that we could look at this fraction notation here. So when I see this, I say, all right, A over B, to me, that looks like the number of times it happens divided by the number of times it doesn't happen. And so just sort of as a guess, if we think about number of times it happens divided by number of times it doesn't happen, what I think about doing is I think about saying, all right, why don't we just try this out? Why don't we try taking the number of times that it happens, which maybe as a probability, we could just say, hey, 42, and divide it by the number of times that it doesn't happen. Well, if it happens 42% of the time, then it doesn't happen 58% of the time. You'll notice that that's just sort of the opposite of it. 42 plus 58 would add to 100. So we're just saying, hey, if something adds, if it happens 42 times and it doesn't happen 58 times, maybe that gives us the odds in favor. What it turns out is that it actually does. And we have a formula to get this, and it's P over 1 minus P. So if we look at this a little bit more carefully, we're going to say, I'm going to go ahead and actually just erase that for a second. Let's go ahead and look at P over 1 minus P. So the probability we said is 42%, which let's go ahead and write that as 0.42. Well, we divide that by 1 minus 0.42, and we get 0.42 divided by 0.58 exactly. And you notice that looks very similar to what we had before. Maybe I can just move my decimal place over 2 on each of these, and I'd have my 42 over 58. And there we go. We've got that all right there. Now, we've written this as a fraction. And what we want to do always with fractions is we want to simplify them. So let's go ahead and actually do that. Let's give a little bit more space here. We want to take this 42 over 58. We actually want to simplify it down. So if we were just to start off by noticing that these are both even numbers, we could just divide them both by 2, and we would get 21 over 29. And to me, that looks about as simple as you could make it. We can't really simplify 21 over 29 anymore. So what we're saying here is that the odds in favor are 21 over 29, but recall that we generally like to write, instead of as the fraction, we like to write it here. So all we do is we just take this fraction, we put the A there, we put the B there, and there we go. We have the odds in favor. So we'll go ahead and just say, hey, odds in favor are going to be 21 to 29. And there we go. And we can backtrack and think about this in sort of the reverse scenario. If I were to have told you that the odds in favor were 21 to 29, you would say, all right, there are 21 favorable outcomes. Remember, this stands for A, and there are 29 unfavorable outcomes. So how many total outcomes are there? Well, there's 21 plus 29. And how many of those outcomes do they win? 21. Well, 21 divided by 50 here ends up being exactly 42 over 100, which is exactly that 42% that we found. So it works going backwards as well. Now, we have the odds in favor. That's great. It's actually really easy to find the odds against at this point. The odds against are just going to be the reciprocal of this, as we've seen before. We've seen that if the odds in favor are A to B, the odds against are B to A. So all we have to do is just flip it. Let's go ahead and do that. 29 to 21. And there we go. There's our odds against. Now, what we want to be careful about here is we want to make sure that we've simplified this as much as we can. What a lot of people will do is they'll accidentally just stop right here. And that's bad. We don't want to do that. If you were to say, all right, I have 0.42 over 0.58, so this is going to go to 0.42 colon 0.58, and you say, hey, that's my odds in favor. While you're not wrong in doing that, it's not very helpful. It's not very helpful for someone to see, oh, there's 0.42 favorable outcomes and 0.58 unfavorable outcomes. That just doesn't really have a nice ring to it. It's kind of hard to think about in a real setting versus saying, oh, they win 21 times, or this event occurs 21 times and it doesn't occur 29 times. That's a lot easier than saying it does occur 0.42 times and it doesn't occur 0.58 times. So what we want to do is we want to do these extra little steps here to simplify whatever fraction we have. We want to simplify it into whole numbers and reduce it as much as we can. So this step here, I've turned that fraction into whole numbers by just moving those decimal places accordingly and appropriately. And then once I have it in whole numbers, now I just simplify as we always do with fractions. And once it gets simplified as far down as you can get, there you go. You're happy, you're done, and we have our odds in favor, and then thus our odds against. What you'll probably notice as well here is that the odds against, we do actually have a formula that we could use for it. Let's go ahead and put this all off on its own as well. Put that off to the side. So we do have a formula for odds against, and it turns out to just be the reciprocal of the odds in favor. You'll notice that if I just do 1 minus p over p, that's just going to end up with 29 over 21, which then would go to that right there, exactly as we did right here from here. So same work there for odds against as in favor, just I think it's a little bit easier just to flip it. But we do have these formulas. We've got them right there. So if we're given the probability of an event occurring, we can find the odds in favor and the odds against. So that'll be it on odds. Just as a quick recap of everything, starting off, when we're given odds in favor or odds against, that tells us whatever is written down, that gives us the number of favorable and unfavorable outcomes. And from there, everything is at your disposal. Once you have the number of favorable and unfavorable outcomes, you could find probability, and there you go. We could also go backwards with it. And given probability, we could work backwards and find the odds. And therefore, once we have the odds, we could have the number of favorable and unfavorable outcomes. So there we go. That's odds, and we'll go ahead and call that the lecture.